Chapter 6 is huge for us, and that's part of the reason why I wanted you to start with the baby steps on your own, so we didn't have to do a lot of crunch time in class and possibly gloss over stuff. We start with the standard normal distribution. It's really not that complicated, and we're going to repeat a lot of this when we start class on Monday. On Monday, we'll start with the normal distribution. The reason this is called the standard normal distribution is when you have a standard, that's the thing that you measure everything else against. So in this case, the standard normal distribution is like the perfect normal distribution. It never happens in real life, or let's say it hardly ever happens in real life, but it's the standard that we want to reach. Standard normal distribution has 4 different characteristics that you need to be familiar with. First of all, a standard normal distribution and a normal distribution, they're going to be probability distributions. So we're still talking about probability here. The standard normal distribution is what we are talking about when we refer to a bell-shaped curve. I know you've heard that term before, bell-shaped curve. That's what we're talking about when we talk about a normal distribution. So, bell-shaped, and it's symmetric about the mean. Symmetric means this is the middle, and in a standard normal distribution, our mean is 0. If we look at the left-hand side of the curve, it's exactly the same as the right-hand side. If I were to take this curve and fold it in half, approximately on the red line, because I'm not that great of a drawer, the 2 halves would match each other. The mean, median, and mode are all 3 0. The mean of 0 means that is the arithmetic center. If I took all the possible values, added them up, and divided by how many values there were, I would get 0. The median means it's also the middle. It's the exact center. And the mode means that it's the most popular answer, which means it happens at the peak of the curve. The most popular is the tallest part of the curve. Because it is a probability distribution, if I was to figure out the entire area under the curve, the area would equal to 1, because all probabilities would equal 1 if I added them up. Now, let's talk about this drawing. The number line at the bottom is a z-axis. Z is what lets you know you're talking about standard normal. Remember, this is our fantasy. This is the perfect curve. The perfect curve, think of it like the curves of your dreams. So zzz, it only happens when you're sleeping. But the standard normal distribution has a z-axis, and that's just a number line. The actual distribution is this blue curve that's above it. So when we talk about the distribution, we're just talking about the blue curve, and it approaches infinity in both directions. That means the blue part goes on forever to the left and forever to the right. Forever both ways. It also gets closer to, but never touches, the z-axis. That is a typo because I stole this from the normal distribution slide. Now, the number line, if we have a standard normal distribution, the mean is 0. The tick marks, which you'll see when we do the normal distribution, the tick marks we just counted by 1 on a z-distribution, and that's because the standard deviation is 1. In any kind of normal distribution, you put the mean in the middle, And your tick marks you count by standard deviations. This is the perfect setup. Alright, so there are some other things that we should know and commit to memory about a normal curve and a standard normal curve actually. If I have the mean in the middle and I go one tick mark above and below the mean, then the place where I am on my number line, my z-scores is what I call them. If I go between the z-scores of -1 and +1, approximately 68% of the curve falls between those two tick marks. If I go to where the z-scores are between -2 and +2, that encompasses about 95% of my curve. And if I go one more time to 3 z-scores above and 3 z-scores below the mean, that is about 99.7% of the total area. 99.7% is really, really close to 100%. So most of my curve is between 3 tick marks above and below my mean. Now, since 0 is the mean and 0 is in the middle, if I go less than the mean or if I go greater than the mean, both of those values are 0.5. So the probability is 50-50 whether you go above or below the mean. That comes from the mean also being equal to the median. The median, half is above, half is below. You have some practice on the ones that you should know on site. You can either pause this now and fill those out, or you can continue with this and do it all at the same time. But obviously, we can't really have a very interesting class, a very interesting investigation of even a standard normal distribution if all we do is talk about the specific tick marks and going from 1 to -1 and 2 to -2 and 3 to -3, and that's it. So when we don't want to do a value that comes with the empirical rule that we just talked about, we do have a calculator function that'll help us find the area under the curve. It's a normal CDF, and it's found in the same place that your binom was, except it's right up at the top. Now with your binomials, you had to worry about whether you were doing exactly 1 or if you had x's that are more than 1. We never use the normal PDF. We're always talking about greater than, less than, or in between. So we'll always use normal CDF. And then we only have to type in 2 numbers, the lower limit and the upper limit. I'm talking about numbers that are on that z-axis. So find the numbers that are in the problem on your z-axis, whatever they might be, and we're going to type them in the order they would come on the number line, from left to right. So here we have some examples of what it would look like if we didn't do something symmetric. If I wanted to know the probability that something fell between a z-score of -2 and a z-score of +1, that's not one of those numbers that I should have memorized. So to figure this out, I need to use my calculator. And I would hit my second vars, go down to my normal CDF, and all I need to type in is -2, 1. And then since this is a probability, I round it off to 3 decimal places, just like I do any other probability, and I get 0.819. If I want to know the probability of picking a number that falls between 0 and 2, again, that's not a symmetric thing. That's not something that I memorized. So between 0 and 2, I just get my normal CDF, left to right, 0 to 2. Type that into my calculator. It's a probability. I round it off to 3 decimal places. I get 0.477. And the last example I have here, between -3 and +1, that much of the curve. Again, if it's not symmetric, if it's not the part that I should have memorized, I go to my normal CDF, left to right. 3 decimal places makes 0.840. Now you've got a bunch of these that you can practice, and you should. You're really just getting the feel for the calculator right now. It helps if you also draw the pictures or fill in the pictures when they're provided for you, just so you can get a visual image that you're starting to associate with the press. Now, all those were in-betweens. These just go left or right. That brings us to a different kind of issue. If I want to know the probability that z is less than 1, here is 1, and I want to know the probability that z can be any of these values from 1 on down. So it's still a normal CDF. But I have to type in how far left am I shading, and then how far right am I shading. Well, you have to go back to the first slide, which gave you the characteristics of a normal distribution. How far does this normal distribution go? It goes forever to the left, not just to 3, but forever. Well, I don't have a number for forever to the left. So, I'm not going to draw it, but we're going to figure forever out here. That is going to be 10,000 to the left. So, -10,000 is negative infinity as far as we're concerned. Then my rightmost value is 1. So if I do my normal CDF, I got to do -10,000 and then 1. And I get a probability of 0.841. Now what if I want to go to the right? What if I start at -1 and I want to go forever to the right? Well, if I do that on my normal CDF, remember you have to list these things in order on the number line left to right. So now the -1 is my leftmost limit, but I'm going forever to the right. Forever to the right is not going to be -10,000, because if we go to the right, we're going in the positive direction, and so that would be +10,000. That gives me exactly the same answer, because it's kind of symmetric. What if I have a z-score, though, that's a decimal? Sorry about that. That was a dog bone. If I have a decimal, it doesn't matter. All I need to know is left or right. So if I clean up some of this, just so I could look at it. Sorry, I cleaned up too much. If I want to talk about 1.15, that's somewhere in there. I don't know where. But I want to talk about from there, and I want to go left. I just need to see that so I can see my left and right. So if I do my normal CDF, I'm going forever to the left. That's my negative 10,000. My rightmost limit is my 1.15. Do that on my calculator. Round it to 3 decimal places because we're talking about probabilities, and that's 0.875. Before you start doing this section, I heavily advise you to practice the first thing that we did. Because now we're going to look at things and we're going to go backwards. Now, if we're going backwards and you see anything talking about 95% of the area, 95% of the area, that's the one that was 2 tick marks. So that's between a z of -2 and +2. 99.7 is almost the whole curve. That was between -3 and +3. 68% of the area, that was the central part. That was between -1 and +1. Half the area is to the left of z of 0, and half the area is to the right of z of 0. Anything else I want to do that's not one of those that I multiplied, I need my calculator. Again, the command is right under the normal CDF. It's called inverse norm. Inverse is kind of the opposite, so it's the opposite of doing a normal distribution. The difference between using inverse norm and normal CDF is inverse norm, you only have to type in one number. And the number you type in is the area that is to the left of whatever z-score you're looking for. So you're going to be given an area, you're looking for a z-score. Let's look at a problem. If I look at this picture here, what the picture is telling me is that the shaded area is 40% of the curve. And I'm looking for the z-score that divides the shaded area from the unshaded area. Now, since the area they tell me is already to the left of the z-score, all I need to do is on my calculator, I need to do inverse norm of 0.40. Now, inverse norm of 0.40 doesn't equal anything. If I do the inverse norm of 0.40, the answer I get is my z-score. So when I do inverse norm and I get the answer, my answer is z equals whatever the calculator says. Z-scores always go to 2 decimal places. Don't go more. If you do, your answers are going to tend to be slightly off on my stat lab, and it's really going to annoy you. So my z-score turns out to be negative 0.25. Now on the second one, I'm looking for the cutoff here. It tells me the area that's to the right is 30%. But that doesn't help me I can't inverse norm 30% and get this z-score over here. I have to inverse norm the area of the curve that is to the left. Always to the left. Well, this is just like when we did the binomes and had to do one half of the chart or the other. If the area is 30% over here, shush, that means it's 70% on this side. So I inverse norm 0.70, and that'll tell me the correct z-score with the correct sign. 2 decimal places is 0.52. Now the last one is, what do I do if I have an area that's in between? It's not 68%, it's 70%. I can't just sort of fudge it. I need the exact z-score for here and for here. So the area in between two z-scores means I'm going to have two z-scores. Now, there's a couple things we have to be aware of. First of all, the curve is symmetric. That means everything on the left matches or mirrors everything on the right. If 70% of my curve is in the middle, that means I have 30% of my curve in the white. But half is here and half is here. So that means the area here to the left is actually 15% or 0.15. The area to the right is 0.15. If I find the z-score for this area here, I inverse norm 0.15, and that gives me a z-score of negative 1.04. Now if I want to find this z-score, if I have 15% that's to the right, the total amount that's at the left is 0.85. 85% of the curve is to the left. So if I want to find the total area to the left of the second z-score, I inverse norm 0.85. What happens when I inverse norm 0.85? I get a z-score of positive 1.04. You see how these two are the same? That's because if I have 15 down here and 15 up here, the symmetric part says that my z-scores are going to be in the same place. It's just that they're going to have different signs. The one below 0 is going to have a negative. The one above 0 is going to have a positive. This is always going to be true if you have an area in the middle. A shortcut, when you write the z-scores, you could just say positive and negative 1.04. I believe on the Stat Lab you have to list them separately, separated by a comma. Please practice these and be ready to know how to use your calculator and have some idea of what a z-score is when you come to class on Monday. Otherwise, have a good weekend.